That is an isotropic break. That is a perfect curve. No other materials have reacted quite like this. All right, guys, today we're talking about FluorX PVDF from 3DXTech. Now, PVDF is polyvinylidene fluoride, which is a very high-performance polymer with exceptional thermal and chemical resistance for industrial-grade printing. Rated for uses up to 150 Celsius, this filament can be used in the most demanding applications and under extreme conditions. PVDF is resistant to most chemicals and solvents, making it a great fit for applications that will be exposed to harsh environments like acids and solvents. FluorX is made using Arkema Kynar PVDF, which is one of the biggest brands out there, and it's got very, very, very good abrasion resistance, much like nylon, low smoke and flame characteristics, long-term hydrolytic stability underwater, even resistance to nuclear radiation. Wonder material. Let's talk about it. So here's the box you'll get when you buy it from our online store at visionminer.com/materials. Comes in this box, comes on this spool. It's a very cool material. Now, if you get this and it's not sealed, don't worry about it, because you don't actually have to dry this filament. It's one of those few that doesn't absorb moisture, and you don't have to store it in any special way to get good prints. So that's a big plus with this material. Does like warp, but we'll talk about that in a little bit. By the way, when you order online from us at visionminer.com, you'll actually get 3% back in rewards, which you can use for anything in our store, from adhesive to nozzles to machines to more filament. So definitely sign up for that, check that out, and let's talk more about where you're actually gonna see this material in the real world. PVDF is commonly used as insulation on electrical wires and in electrical situations because of the combination of flexibility, low weight, low thermal conductivity, high chemical corrosion resistance, and heat resistance. Most of the narrow 30-gauge wires, especially used in wire wrap circuit assemblies and printed circuit boards, is PVDF insulated. It's also used in tactile sensor arrays, inexpensive strain gauges, and lightweight audio transducers. In the biomedical sciences, PVDF is used in immunoblotting as an artificial membrane, as well as a membrane filtration device, and it's often seen in the form of syringe filters or wheel filters. PVDF is used also for specialty monofilament fishing wires, sold as fluorocarbon replacements for nylon monofilament, which is fishing wire, and the surface is harder, so it's a little more resistant to the abrasion and sharp fish teeth. Its optical density is also lower than nylon, which makes it a little bit harder for the fish to see. Now, it's also denser than nylon, making it sink faster towards the fish. And in case you're wondering, yes, you can actually make fishing line on a 3D printer. It's not normal, but it can be done, and some of you probably know exactly what I mean. So let's get into the high temperature processes. PVDF is used as piping, as sheets, as internal coatings in high temperature, hot acid, and even radioactive environments. Let's get into real quick, what kind of machine do you need to print this filament? It'll print on almost anything. You need a nozzle temperature of 245 at the minimum, up to 265 C or so, and that means your Ender 3 can extrude it. Now, as far as the bed temperature goes, you need 90 Celsius to up to 110 or so, and our nanopolymer adhesive actually works fantastic keeping this stuff down on the bed. It does tend to warp a lot, much like nylon or ABS, so that stuff really, really helps. As far as print speeds go, you're starting out around 20 to 40 millimeters a second until you become familiar with the way it flows, and then you can go faster. And as far as cooling fans go, at those speeds up to 40 millimeters a second, you don't really use any fan, but as you go faster, 20 to 40% fan, depending on your fan setup, tends to help a little bit at those higher speeds. Now, as far as drying this filament, no, you don't have to dry this filament at all. It'll actually print wonderfully straight out of the box, straight out of the wherever you pull it out of the water, it'll probably print fine. Almost every other filament on the market, you have to dry it, and we've got a dry kit for that at visionminer.com/dry kit with vacuum chambers and everything else, but you really don't need that for this filament. Now, as a safety note, this polymer does start to degrade at temperatures above 290 Celsius. So make sure that you keep your extruder temperature below 290 in order to avoid that degradation, the off-gassing, the fumes, and the mechanical property loss is definitely not something you want. So keep it below 290, but you've got a wide range, you can do a lot. Now, the fumes are another great reason to pick up a BOFA filtration system, which I'll talk more about in a minute. We've got those on our site as well. By the way, if you're enjoying this video, please hit that like button. It helps us out on the algorithm of YouTube and the YouTube gods, and it tells them our content is valuable and you want more of it. Well, while you're at it, you might as well subscribe down there, because we got a lot of these videos coming out, more comparison videos, and all kinds of content you won't want to miss. Now let's talk about some basic material specifications. You've got a melting point of about 170 Celsius, which is a heat deflection temperature of 158 Celsius. So you can actually sterilize PVDF without any issues, and that makes it good for the medical industry. Now, getting into strength specs, for tensile strength, you get around 51 megapascals, and the tensile modulus is around 2450 megapascals, but keep in mind the way your part's printed and designed and the orientation at which it's printed was going to have a dramatic effect on strength. You'll always lose a little bit of percentage in the z-axis depending how it's designed. Now, this particular filament PVDF, I've noticed, has really good layer adhesion, so not too much concern there, but you always want to keep that in mind. Now, if Z-adhesion is your biggest concern, check out PCTG. It's actually got better Z-axis adhesion than it does in the XY, which is crazy. Anyway, more on that later. Subscribe. We got videos coming out there. And if you want all the other data on elongation at break and everything else, we've got all the data sheets on our website at visionminer.com/data. So get all those juicy details on there, and let's talk about some specific environmental factors. This stuff is inherently UV resistant, very good in sunlight and ultraviolet radiation. The hydrogen fluorine bonds are very, very stable, making it excellent in the sunshine outside for years at a time. It's also got very good abrasion resistance, similar to nylon or Delrin and the UHMW-PE for high wear applications. It's got great long-term hydrolytic stability, meaning you could use this underwater with no adverse effects over time, and it's non-hygroscopic, meaning it doesn't absorb moisture from the air, so there's no drying or special storage that's needed to keep this filament ready to print. It's also got excellent resistance to a broad range of chemicals such as automotive fluids, oil, gas, and lubricants, fully halogenated hydrocarbons, alcohols, acids, and bases. It's really good when it comes to chemical resistance. It's also really good with smoke and flame, in that it has very low smoke and flame characteristics, as the base resin is actually rated UL94V0, so it's flame retardant and resistant. This stuff's even resistant to nuclear radiation, for crying out loud. Anyway, we're going to break and burn some of these parts here in a little bit, so stay tuned. We'll get right around to that. As far as electrical properties goes, it's used all over the place as an insulator. I guarantee almost every electronic device you own has some of this stuff in it somewhere. Next, we've got the biocompatibility, certifications, and sterilization. Now, this is probably not a material you'll use for an implant, but it comes with a UL94V0 flammability rating, which is huge, and it can be sterilized for medical tools and other applications involving harsh chemicals. Almost any harsh chemicals. Very, very cool stuff. Now, let's just move right along and check out some of the example parts we've got here. We'll start with this one right here. This is a PVDF vase. As you can see, the texture is very interesting. It's not perfectly the same color or sort of transparency as a lot of other materials. You can sort of see my finger sticking through there. And it's got an interesting texture. Very, very, very nice, very cool. I mean, it's pretty beautiful. One cool thing I like this, similar to polypropylene, is I believe this is completely watertight, so you could actually fill this up with water, and unlike PLA or some other materials, you're not gonna have to worry about it dripping water through the tiny little porous seams. Now, yeah, very nice, very nice. Now we got also some jigs and fixtures. This stuff is great for jigs and fixtures because of the high temperature and the abrasion resistance. So if you're making, tooling or fixtures that you're putting thousands of parts in and out of every single day, it is very, very good for that, and it's strong. It's not a weak material. But we got very nice surface finish on here. You still see a little bit of that texture. It's kind of a sheen. It's got a sheen to it, but it's mostly matte. It's not very, very shiny, but there's this weird, like, internal pearlescence that's coming out. As you can see right here, we had a warped corner, so that's something where you would want to put like a lily pad or something like that, just on that corner, just to hold it down. And when we reprinted it over here, it was much less. I don't know if you can see that comparison. It's much less, just using our nanopolymer adhesive, no brim, no nothing. That's how we do it here. Brims are a bad word. Well, thank God for nano adhesive. Anyway, yeah, you can also see the detail that came out here at the top on that little circle area. It's supported by a tiny little support thing up there. Overhangs look pretty good. Overall, I mean, oh, this is strong. Holy crap. We're gonna break some parts in a minute, but there's no crackling or anything. God, yes, this is impressive. I love strong parts. Okay, let's go right into, this is a electronics enclosure. It's a cover for something that we printed in every different material. Stay tuned for that video where we compare them all. But as you can see, it came out very nice. This bridging across this long area did pretty well. It didn't fully bridge. We did have support under there with one separation layer. And it's not the cleanest. It's not quite as clean as I believe the PA12 that we did, but it's still pretty darn good. And the removing the supports was not hard, not too bad. It does look like it's got a little bit of warping there. Now you'll notice, see how that kind of has that bow in it? It's not a perfectly straight line. It is something you will encounter as it's doesn't have any fibers in it or anything to keep it dimensionally accurate. So as you design your parts and as you print, something to watch for. Man, beautiful. Same with the vase, by the way, on that last point. You can see here, I don't know if you can see that on camera, but it's not quite perfectly smooth. Not quite perfectly smooth, but still very nice. Still worked out well. Okay, now before we get into breaking and burning these parts, which we will do here in just a second, we got these sample bars. So if you need a test to make sure this is gonna survive in hydrofluoric acid or chlorine or whatever kind of chemicals you have or temperature environments, we do have these sample bars that we can send out. So give us a call, we'll talk to you about your application, and we'll send you a few different materials that may work for it so you can actually touch and feel it and actually, test it if needed. Anyway, yeah, let's get into breaking. Let's get into some of the good stuff here. So before I do, safety first, safety glasses. I have no fears of this material actually exploding, but safety first. Safety third? Wait, safety. I don't know. Safety, guys, safety. I'm gonna pull out my handy dandy little Babco vise and get this puppy ready. And I'm actually gonna start with a vase. I'm gonna do the test where I shove my thumbs into the vase and we're gonna see how much it deflects, if it bounces back, if it breaks along the layers, if it breaks down the layers, how it's gonna break. So let's just do that real quick. Rob thumb test, take one, go. All right, here we go. Woo! Oh, that shattered immediately. It shattered, wow, look at that break. That is an isotropic break. That is a perfect curve. What? No other materials have reacted quite like this. That is impressive. Now we did have obviously the layer separation at the top as it does begin to break. Now that broke at like a 15-degree angle, not noticeably up the layer lines at all. If I take the top and just squeeze it, you see you can get that full deflection. So we might have needed to print a little bit hotter or faster down here to get the full layer adhesion, but let's see if I can break it up at the top. Ooh, no. Oh my God, I can bend this thing? Here, let me pull off the bottom. Wow, yeah, you can tell from those lines that's not breaking on the layers like the most. It is breaking on the layers a little bit, but that is some good layer adhesion. Now, if I squeeze this and give it some torsion, oh dude, there's no way I'm breaking this. There is no way. I'm gonna stick it in the vise. Yeah, this is pretty good. This is really tough stuff. Oh, I love it. Holy crap. Okay, let's get on to the next thing. I'm gonna take one of these sample bars here, and I'm just gonna put it in the vise and use the power of Rob to break it. And we're gonna see how it breaks, how it bends, what happens, what the inside looks like, how tough it is. Let's go, let's do it. All right, here we go. And I'm just gonna pull back here. Woo! Okay, as expected, no explosion, no parts flying everywhere. It didn't even break, dude. It didn't even crack. Like, let me go back and forth. Let me go back and forth like 20 times. This stuff, it's barely affected. Let me show you real quick. So you can see the color change in there like a zip tie, right, nylon. But there's no signs of it breaking apart whatsoever. Let me just give this a few. I'm just gonna go back and forth and back and forth, back and forth, back and forth. Come on, come on. Holy mother of, okay, now we're getting some heat in there and the friction, and it's not going anywhere. Oh, give it a nice twist. That's not going anywhere, dude. This is cool. This is cool. This is not something you see with a lot of 3D printed plastics. And as you can see there, after all that back and forth, it has, it's got a cavity sort of there, but it's not breaking. It's not shattering. I can only imagine what the impact strength from this material is. Woo! That is super impressive. Look, I can bend this all the way down onto itself. Nothing happening. Bring it right back. Not quite as good as it was before, but all right, let's take it the other way. Let's do full. Can I get it to break? Can I get it to break? This is probably, there's material scientists watching right now, and they're like, no, you're not gonna get it to break. This fool's errand. It will not break. Oh my God. Holy mother of. Yeah. Anyway, I'm not getting this to break. This is a good time. So, since I can't break it, let's burn it. Let's take this over here. I'm gonna grab some of this broken vase. I'm gonna take a chunk out. Maybe a little bit longer chunk. Okay, this is super thin. We're gonna do the thin part, and then we're going to do the sample bar. I'm gonna burn both of them, see how it burns, see how it drips, everything else. Before I do, I'm gonna pull out the BOFA Print Pro 2, which is a awesome little machine for fume extraction. It's got this flex hose that I can do, and you can position this however you like. I like using it for soldering in the office or even grinding stuff down. It works great for that stuff. And we've got the Print Pro 3 and Print Pro 4 and everything, and you can actually circulate heated chambers with those models. This one just evacuates into there, but I'm gonna turn this thing on, and let's get to the fire part, guys. Okay. I'm gonna do the thin side first. Now this does have the UL94V0 flammability rating, which means it should self-extinguish and it should have minimal fumes. So let's check this out. 10 seconds under flame and go. 3, 6, 7, 8, 9, 10. All right. It just flopped. Didn't light on fire. Didn't smoke a lot. I'm smelling a little bit of, it smells like super glue. Cryoacrylate or whatever that is. All right, let's see if we can get it to light on fire. Nope, self-extinguished. Let's really, come on, light on fire. Light on fire. Now you can see it's burning, but it immediately puts itself out. And then it only smokes for still a little bit of smoke. It's pretty much done smoking. That is one of the behaviors of the UL94V0 flammability ratings. This is a self-extinguishing, low off-gassing, low fume plastic. So if you're using something in super high temp environments or in open exposure to flame, this is a good one, because if it lights on fire, it's not gonna burn your whole house down, it's actually gonna put itself out. Very cool. And then if I move it around, it looks like it does turn into carbonization. That is a little bit different from the non-high flammability rating materials that we've done. It doesn't carbonize as fast, so that might be a function of the actual polymer. Let me do one more real quick here. Oh man, I cannot get it to stay on fire. That's good, that's really good. So if you need to put something near flame, this is a good choice. All right, let's move along to the thick piece, this one right here. Now you can see the lettering there. I'm just gonna burn on the lettering so we can see what happens to the material, how it sort of melts. But I'm gonna do another 10-second test on this side right now to see how the thicker bar reacts. 3, 4, 5, 6, 7, 8, 9, 10. Well, there we go. You can actually read it now. Let me get some in there so you can read the whole thing. PVDF, very good. It wasn't too affected. It did start bubbling sort of out near the edges out there, but nothing too crazy. Let's try to get the light on fire. Let's get this whole thing melted. It's really interesting. It's like as layers melt away, the inner layers are revealed and start to bubble, but it doesn't catch on fire. It just does not catch on fire. You can see that there, it's like dripping, and the inner stuff that hasn't burned yet is appearing, and all of this down here is turned into like carbon. It's a little bit stringy like that. As with any melted thermoplastic, you can play with it, it's okay. We all do at some point or another, right? Oh my gosh. The letters are almost gone. That's pretty sweet, man. Very flame resistant, low off-gassing, low smoke. That's some pretty cool stuff. Is this too hot to grab? Ooh, yeah, a little bit. So if you go like that when it's hot, or coming out of the nozzle of your 3D printer, you can actually make fishing line. Just get that right temperature and start pulling. You know, put it on a spooling machine, and just buy the big filament, you can make the small filament. Anyway, all jokes aside, this is a great material. I'm gonna turn off the BOFA here real quick. Really, really cool material. If you need sterilization capability, super chemical resistance, if you need electrical insulation, if you're putting parts in nuclear reactors and you need them to be really tough with really good layer adhesion, this is a great material. This is really, really good stuff. We've got it on our website right now in stock, visionminer.com/materials. Check out the BOFA at visionminer.com/BOFA. The glue, of course, works fantastic with it. You don't really need our metal spools for this one because it's not very brittle and you don't have to dry it at all. So, you know, that's just a plug. Anyway, that's all we got today. Let us know in the comments below what other tests we can do to show you how these materials behave. And we can print all the different materials and do the same test on them, but give us some ideas down below and we'll make sure to do that for you, because we want to get you the information you need to make the right decision on your material choices and 3D printing systems. Here at Vision Miner, we specialize in high temperature, high performance filaments and plastics that are extremely high temperature functional materials. That's all we do all day long. So thanks for watching. Have a positive rest of your day, and I'll see you on the next video.